earthquake can cause a building to shake and collapse. That's why engineers design special buildings to be strong and safe during earthquake. Our model shows how we can use simple ideas to reduce damage from shaking. Firstly, we learned that during an earthquake, the ground shakes in many directions. This can make buildings fall if they are not built properly. One way to make buildings safer is by using base isolation. This means putting flexible part like spring or rubber under the building. This helps absorb the shaking. In our model, we use spring as the base to show this idea. We also found out that lighter materials are better because they feel less force during earthquake. So we use ice cream stick and a box to build the model. Another idea is the steel design, which means raising the building above the ground. This helps protect the building from both shaking and flooding.
So for the data, we have the purpose of testing. What is the main purpose of testing? It is to assess the earthquake resistant capability of the house model. The model was constructed with elevated spiral cylindrical columns to reduce the impact of the vibration of the earthquake by allowing movement and energy absorption. So the first one is testing method. Lateral shake was conducted by gently pushing the box base of the model in horizontal direction. This test is similar to what happened during earthquake. So the third one is load test during vibration. This test purpose to know the ability of the structure under a combined loading conditions. A small weight were added on the top of the mock-up house to simulate the load of furniture, equipment and even a human weight. The house then subject to both horizontal and vertical shakes and vertical vibrations. Okay, first one, the structural stability. The house remained intact and still throughout all testing stages. The spiral cylindrical supports allowed limited movement during shaking, but returned to their original position afterward. This indicates that it is elastic and shock absorbing behavior. There are several limitations that have been noticed, such as slightly bending on the box occurred during a stronger vibrations is applied. This affects the overall firmness. As the model is made from the used materials, so it can't be replicated structural loads. A full-scale testing or a computer simulation will be needed for accurate validation. To summarize, the design that have been built showed a good potential in resisting small to moderate simulated earthquakes. The raised base and spiral supports effectively reduce direct shock transfer from the ground to the main structure. This testing confirms that using such design features can help to improve the resilience of buildings in earthquake-prone areas, especially for light structures. Thank you.
Next, I will explain six of the discussion. First is innovation spiral plastic column. Its flexible column help absorb shaking. We use spiral plastic tube as column because they allow some movement. This reduces the impact of shaking on the house similar to the base isolation system used in real earthquake resistant building. Second, elevated slit design. It prevents direct impact from ground vibration. The house is built above ground level. This helps delay and reduce the transfer of vibration from the ground to the upper structure. That is use of lightweight material, less pressure and better stability during shaking. Material like ice cream, stick and box are light, which means the structure is less likely to collapse during movement. They are also easy to work with. So, fourth, structure balance. Weight is distributed evenly across all columns. We make sure the model is balanced. This helps keep the house upright and prevent it from tilting or falling when shaken. 5. Strong connection using hot glue. keep part from falling apart during shaking. Hide glue was used for all joints because it dries fast and holds material strongly. This helped keep the walls, roof, and floor attached firmly. 6. Real world learning and application. Understand how earthquake safe buildings are designed. This project talks us that real structure need to be more than just attractive. They must also be safe and stable. The principle we use can be applied in real building with stronger material.